His favorite part of the job is testing the products. He doesn't pedal. He uses his upper body to pump himself up to 35 miles per hour, the speed he needs to get airborne.
Great.
Okay, once again, in this case, he's getting mechanical energy.
Like when you look down on,
so which means that there's a propulsive force acting on the motorcycle.
on the ramp,
He's not pedaling, but he's moving his body back and forth.
like that, you focus on coping, which is that.
So because he's using his body, the mechanical energy is coming from his body. So what kind of energy does the body have?
Bar right on top. And once you stop.
All right, so he's using his muscles as a propulsive force. So his muscles are converting a form of energy that the body has. It's converting it into mechanical energy, right?
Focusing on that.
So what kind of energy does your body have? Okay, so the body has what kind of energy? It's not a trick question. So what is the type of energy that the body contains? So the body is going to have potential energy, but what kind of potential energy? The sort of potential energy that the body has is, this is a trick question. Okay, guys, the body is going to have what kind of energy? It's got chemical energy, right? Okay, so you get the energy from the food that you eat. All right, so it turns into heat. That's the reason why everything is going to be expressed in terms of calories. So the body takes the chemical energy, turns it into heat through muscles, and through muscles, it uses a propulsive force to increase the mechanical energy of the bicycle. All right, so your body, the muscles start to act like a propulsive force. Okay, so when there's friction present, mechanical energy is going to be lost. Lost energy is going to appear in the form of heat, sound. If there's too much friction, fire. Regardless, even if the mechanical energy is gained or lost, makes no difference. Energy always gets converted from one form to another. What that means is the total energy is still going to be constant. So what that means is the total energy will be conserved. It's known as the conservation of energy. Simply put, energy cannot be created or destroyed. But it's constant. Just about in all processes, energy always gets converted from one form to another.
Sacramento, California. Engines roar and tires screech. The National Hot Rod Finals get underway. Veteran driver Hans Kussel rolls to the starting line.
All right, so before you turn on the ignition, what kind of energy does the car have? All right, so it's going to be chemical potential, right? So, but that's the gas in the tank. All right, so you turn on the ignition, what happens? Engine is going to start to run, so which means that chemical energy is going to turn into the kinetic energy of the engine. Within the engine, there's a lot of friction, so it's going to turn into heat. Of course, you hear the sound. And then as soon as you apply the gas pedal, it's going to turn into the kinetic energy of the car.
The green light and floors it.
All right, so now the chemical energy through a long process is turning into kinetic energy.
Then disaster.
Now you got a lot of friction. So what does the friction do? It's going to dissipate the motion. Because of friction, the mechanical energy is going to be lost, which means that the car is going to slow down as the kinetic energy starts to turn into sound. So you end up hearing a tremendous amount of sound. There's a lot of friction, so it turns into heat. And there's just so much friction that things will start to glow at that point. It turns into fire as the vehicle starts to break apart. So now it turns into some kind of deformation. The vehicle is deforming at that point. So it's turning into heat, and then the next thing is deformation.
Up in the stands, Hans's girlfriend, Kay Toplikar, watches in horror.
It just exploded in a ball of flames. Everyone who had witnessed that accident was very concerned that Hans would be seriously injured, if not dead.
Despite his 30 years of racing experience, Hans cannot avoid the terrifying crash. It is incredible that he survives.
I knew there wasn't much I could do with it except hold on. At that time, way before I hit the guardrail, I knew I was in trouble.
As Hans roars down the track, he suddenly loses control. He fights to steer clear of the rail, but he can't.
When I impacted that car at the guardrail, I was doing somewhere between 150 to 170 miles an hour.
So the vehicle had 150 to 170 miles per hour worth of kinetic energy, right?
Hans skids in a pool of oil left from an earlier mishap. As he accelerates, the rear tires spin out. His car
So that's the kinetic energy of the car.
smashes into the rail, flipping onto its side. Now he's caught in a fiery death trap, and there's no way out.
So the final form of energy in this case is going to be deformation. Okay. If it's a race car, you want to break the car apart as fast as possible. You want to go from that kinetic energy to the final form, which is deformation, as fast as possible, in order to take the energy away from the driver. Okay, so when the pieces are flying off, it's going to reduce the amount of force available to harm the driver. That's what it means. So you try to take the energy away from the driver, which means that you want to break it apart so that the energy will be taken away in the form of the flying pieces of this car.
I saw sparks coming off in front of the car. I thought to myself, we're probably going to have a fire now. And then all of a sudden, you could hear the grinding of the car when it was sliding down the racetrack. The body was coming off in pieces.
The hot rod
In terms of deformation, you can either crush the car. If that's the case, the energy is going to remain within the vehicle, or you can break it apart. That's much faster in order to take the energy away from the driver.
Disintegrates and the fire burns itself out. Although Honda's in shock, amazingly, he is able to walk away from the wreck.
When I unbuckled myself, I basically kind of rolled out of the car because the car was sideways laying on the ground. When the paramedics came over, that's when I finally realized what I just went through.
Now look at the car. Notice that there's not a single dent on the car. If you angle it just right, take a picture of it, you may be able to sell the car as is. If you put some tires on it, no one is going to even notice that the car was in an accident.
His car is a total loss.
All right, because these cars are not designed to crumple. Okay, because this guy is going 150 to 175 miles per hour. Make it so fragile that on impact, the car is just going to break apart in order to take the energy away from the driver. Okay, so the final form is deformation. The fastest way you can deform a car is by breaking it apart. All right, so we'll put down a deformation in the final form. All right, so speaking of,
Have you ever wondered
Asteroid Impact.
why is the sky blue? And why do flesh-eating meteorites rip through our universe? This ad exposes the God's honest truth.
okay, so all that heat, fire, sound, where's that coming from? Not the Tabasco sauce. All right, here's a movie. It's gonna have asteroid impact in it. Yeah, I'm afraid to ask, how many of you guys know the name of this movie? The chances are pretty good that none of you guys do. How many of you guys seen the movie? I forgot the name. What's the name of that movie? Okay, Armageddon. How many of you guys seen the movie Armageddon? I think it came out like 20 to 21 years ago. I think 1999 is more like it. Okay, so most of you guys are late teens, early 20s. You may have seen it, maybe in reruns. These are old movies, obviously. Believe it or not, this movie came out about the same time as Armageddon did. It's 1999, more like 98 or 99. Armageddon was a better movie. The name of this movie is Deep Impact. The only reason why I know this movie is because of the location. Okay. The scene is shot over at Virginia Beach. I went to graduate school near Virginia Beach. And all special effects. All right, so this asteroid has tremendous amount of energy, right? So what happens through friction is going to turn into heat. So you end up getting this fireball. And then hits the ocean. Immediately it creates a shock wave. Shock wave is tremendous amount of kinetic energy. The shock wave moves about 1,000 miles per hour, guys. 1,000 miles per hour. All right, so it's going to move faster than the speed of sound. And it's going to have tremendous amount of energy in it. Obviously, before 9/11. Director, I don't remember who the director was, but this guy just went nuts with special effects. Okay, this movie was, I think the special effects software, the technology was just newly coming up. And this guy just went everything in this movie with special effects. The storyline was really weak. I mean, look at this scene. There's absolutely, this scene is complete nonsense. Look at the carnage behind this guy. He's trying to read the news. And then boom, it just flies off the scene. It was really, really dumb. All right, so the question is, when the asteroid impacts the Earth, you end up getting all this heat, sound, and deformation, obviously. So where do you get the heat, sound, and deformation from? Where do we get all that stuff from? What's the initial form of that energy? What's the initial form of that energy? All right, so let's focus on the asteroid impact. So you got the Earth here. All right, so the Earth is going to get impacted. So we got the asteroid coming from deep space somewhere. And let's just get the atmosphere up here somewhere. All right, so this thing is going to come in, and then it's going to hit the atmosphere. Okay, so what do you have at this point? You got tremendous amount of friction. So what does the friction do? All right, so it's going to slow it down at this moment. All right, so through friction, we will have heat. If it's coming way too fast, so it's going to turn into light, which means that it's going to be the fireball that you will see. It's going to generate tremendous amount of sound, so it turns into sound. We will end up getting sound waves. And then if it hits the land, obviously you're going to end up getting a deformation crater. All right, so right at that point, it's going to turn into deformation. All right, so these are the byproducts of what friction does, right? So the friction is going to give you heat, light, sound, and then deformation is the final product that you will see on impact. So my question is, what is the initial form of this energy? Okay, so this thing is going to be moving, obviously, so which means that it's going to have kinetic energy. What else? Also, it's going to speed up near the Earth because of gravity, right? So there's a force of gravity acting on it, force of gravity, which means that it's also going to have potential energy. All right, so what that means is it's going to have mechanical energy. So initial form of energy is going to be mechanical energy. So mechanical energy is what gets converted into, mechanical energy of the asteroid is what gets converted into heat, light, sound, and deformation that you're looking at. It's not just the kinetic energy, it's also got potential energy because of the fact that it's moving under the influence of gravity. Okay, so that potential energy also gets converted into kinetic energy, right? That's what it means. Which means that kinetic energy is going to keep increasing as it's getting closer to the Earth. So gravity is going to feed energy into the asteroid. The direction of motion. Another type of deformation.
The principles of a trampoline
Deformation is the final form. It doesn't have to be the final.
are very basic.
Notice that the mat is deforming.
Trampoline are very basic.
So we got a
The principles
trampoline. We got potential energy. Potential energy turns into kinetic right at this point. It's going to be pure kinetic. And then what happens? The mat is going to deform, so that energy is going to get stored within that formation. So that's known as the deformation potential energy, or elastic potential energy. That means the same thing. So which means that the mat is going to store energy just like gravity does, and that's why it's going to have formation potential energy. So gravitational potential energy is going to turn into kinetic energy. Kinetic energy is going to turn into deformation or elastic potential energy. And elastic potential energy is going to turn into kinetic energy, and kinetic energy is going to turn back into gravitational potential energy. Okay, guys. This elastic potential energy is going to get stored. I mean, yeah.
of a trampoline are very basic.
All right, I got to figure out a way to say that. All right, so you have potential energy, it turns into kinetic energy. Kinetic energy is going to turn into elastic potential energy because this mat has something called the restoring force, which means that the mat is going to restore itself to its original shape. It's going to bounce back to its original shape. That restoring force is also a conservative force. So when you do work against a conservative force, like gravity or a restoring force, you end up storing energy in that system.
Up, down.
So the energy gets converted back and forth between gravitational potential energy to kinetic energy to the elastic potential energy, from elastic potential energy back to kinetic energy, from kinetic energy back to the gravitational potential energy. Eventually, obviously, that energy is going to get converted to heat. He's going to feel the pain, and there's going to be better deformation.
Stumble and fall and to be launched into each other. And if two children of different weights are jumping and the heavier child lands on the mat, the force of the mat as it springs back up can be enough to snap the leg bone of the lighter weight child coming down. That powerful rebound effect is apparently what happened.
So when you have multiple people jumping up and down, okay, so what that means is that mat is going to be energized. You notice that mat has a restoring force, right? So every time you do work against it, the amount of work that you do is the amount of energy that you transfer to the mat. So when you have multiple people jumping up and down, more energy is going to be stored in it at any given point in time. Guys, remember, energy is the capacity to do work. What that means is it's got the capacity to apply a large enough force on you to displace you in the upward direction. So it's going to be able to, it's got enough force to propel you in the upward direction, maybe about 3 feet, 5 feet, 6 feet, or whatever. Okay. So the problem happens if your ankle kind of rolls. So you still have the same amount of force acting on your body. It's going to be able to generate a large enough force that's going to propel you in the upward direction, maybe 3, 4 feet in this case. Except because you roll your ankle, the amount of force acting on it is still the same force, except your body does not get propelled. So what happens is it's going to be large enough to break your bone.
Russ Johnson was jumping with two.
All right, so notice that the mat is always energized because multiple people are jumping. For whatever reason, it decides to jump on one single foot. And the surface is kind of curved, so ankle rolls. All right, so there's large enough force acting on his body to cause a displacement, except instead of the body getting displaced, what happens is the bones get displaced in the form of just getting shattered.
It's broken, Chris, I can tell. His ankle wasn't just broken, it splintered into 36 pieces.
which means that the ankle just exploded. It's the same as having someone jump onto your ankle from like 10 feet above the ground.